Have you ever seen Russian dolls? You open one doll to find an identical smaller doll inside. If you keep on nesting these dolls, you will eventually find the tiniest Russian doll nested within them all. A computer science concept called recursion is very similar to the way that Russian dolls are nested. Stanford's encyclopedia defines recursion as when a task is repeatedly done until an ending condition, called a base case, is reached. In this example, the smallest and last doll in the center would be the base case. A recursion function is a function that calls itself. By calling itself more than once, a function can produce multiple copies of itself. Recursive patterns can be found in nature, mathematics, and computer science. First, let's talk about how recursive patterns naturally appear on Earth. The romesco broccoli is a vegetable that is composed of small pointed trees, which are composed of even smaller pointed trees. This same pattern shows up in cacti. Many cacti are formed by a spiral of leaves which stem from a single root location. According to the Journal of Information Technology Research, there is an evolutionary advantage to recursive patterns for cacti. Plants in the desert need to conserve water, and the recursive pattern combines a maximum of surface area with a maximum of flow. The cacti take in more light and filter more waste, allowing them to store water more efficiently. Many plants and other naturally forming structures, such as mountains, rivers, and clouds in nature, all have a form of self-similarity. Self-similarity is a form of recursion where if you look at one small section of a structure, the shape it forms is seemingly similar to the structure as a whole. Looking at a small part of a snowflake, you can also see the pattern of one small section is strikingly similar to the look of the snowflake as a whole.
Next, let's delve into how recursive patterns are prevalent in math. So recursion is a common concept in math. It means that a function is defined in terms of itself. For example, the math factorial function is defined as f of n equals n times f of n minus 1, and f of 0 equals 1. This means that the factorial of a number equals itself multiplied by the factorial of the number minus 1. So with f of 4, it equals 4 times f of 3, which would end up expanding to 4 times 3 times 2 times 1. Recursion always has three parts: a base case, a general case, and a finite number of calls to reach the base case from the general case. In the case of the factorial function, the base case is f of 0 equals 1. The general case is f of n equals n times f of n minus 1. And after calling the f function n times, it reaches the base case f of 0. In math, a function is a relationship from a set of possible inputs to a set of possible outputs. In computer science, the term function means a sequence of statements to perform a certain task. The function in computer science and math look different but work similarly. A function takes several inputs and returns a value as an output. A function may call other functions to help perform its task, but it could also call itself. When a function calls itself, this is called recursion. For example, in this Python code, which calculates a factorial of a number, factorial is the function name, and the base case is shown first, or if factorial of 0 is called, the output is 1. Next is the function calling itself. So if factorial of a non-zero number is called, the output is the input multiplied by the factorial of the number minus 1. As shown, recursive functions in computer science are extremely useful in automating difficult math problems. Surprisingly, recursive patterns also show up in nature, in Romanesque broccoli, cacti, mountains, rivers, clouds, and more.